Alright guys, so this is the Matlab coding for the LSE problem just now. Okay, so I will show you how I do it, and before that we go back to our equation just now. So this is our problem. So this is our set of data. See, we have U and also we have Y, the input and the output. So the input have four values: -1, 1, -1, 1, and the value of Y, four values also. Okay, so finally we will get this value of A and B from this general equation given. Okay, so we have equation but we have unknown, so we find the unknown so that we can use this equation as the system's transfer function. Okay, so we have this equation, we can find any values that is not given in the data set. Okay, so you go back to our Matlab just now. Alright, so the first thing to do as usual is clear the memory of Matlab, the workspace, by using clear all. Okay, so this is the first line, and then what I do is the input U just now I put it as a matrix. So this is the sign to find that to create a matrix. Okay, and then the value is -1 space 1 space -1 space 1. So this is our input. Same goes to the output Y. Okay, so this is the values just now. So we have all the values here, four values. Right, so remember, so this is our command window. This is our workspace, so we have all the values. So if we select the first line and we use right click evaluate selection, or we just press F9, okay, everything in our workspace will be clear. Right, so that is first line. The second line, okay, I use F9. Where is my F9? Okay, F9. So in our workspace appears the matrix of U. So this is the values. These are the values. And then if we run the third line, so we have the values of Y. Okay. Okay. This one is the way for me to create the graph of it. I'll show you later. We straight away to the solution first. Okay. So this is it. I use for looping, okay, to create. Remember just now we have y and y and b. We go back to our this one. Okay, so we need to find this y, create this y matrix and also theta matrix, okay, from this general equation y equals to theta beta times zeta just now. So we want to create this first. Okay, so I use looping. Look at here, I use for k equals to 2 until number of element of u, numer. Okay, just now we have here u is 1 2 3 4 elements, so I put it k equals to 2 until 4. Remember just now our k, okay, our k is 2 3 and 4. Okay, from the problem just now. Okay, so we have set of 1 2 2 3 and 3 4, right? So the value of k is 2 and then 3, and then 4. Okay, and then for the matrix of y from here, for this matrix of y, the k is 2, so we take this value, right? This and this. Okay, so in our Matlab, you can see here I put it first. I assign y as a blank matrix, t also blank matrix, so that this is how we assign values in our matrix. So since this is matrix, not coordinate, okay, so this is the vertical, this is the horizontal. Okay, so n plus 1, since nothing here, so n plus 1 equals to 1. Okay, so I put k y 2. So remember just now we have here y. Okay, the second value is this one. Okay, since k for the first iteration is equals to 2, so k y 2, so we take this value. Okay, second iteration k equals to 3, so y3 is this value. Okay, and then third iteration, okay, k equals to 4. Okay, so y4 is the fourth value, this one, the fourth value, negative 0.615. Okay, and then no more iteration because this is k equals to 2 until 4 only, so k equals to 2, 3 and 4. Okay, for t values we have two column. Okay, so this one is the first column, this one is the second column. Okay, so I put value, I take from the y just now. Okay, k minus 1. So first iteration k equals to 2, so k minus 1 is 1. Okay, so y1, this value 0.44, and I give negative sign there. Okay, second iteration, okay, k equals to 3, so this one is k minus 1 is 2, so y2, this value, negative of it, and then third iteration k equals to 4, so y3 is this value. Okay, so the second column here we put the value of u. Remember, it comes from this. Okay, so for theta we have first column and second column, right? So this is uh, the way to create the second column, right? So the value is k minus u, k minus 1. So k is 2, 3 and 4, so k minus 1 is 1, 2 and 3, the value of u here. So here we take negative 1, 1 and negative 1. Alright, so if I run this, I select and then I press F9, I will get the value of y, capital Y, and also u. Okay, since I do not put semicolon like this is semicolon. Okay, but I do not put it there, so whatever I run, the value will be shown in our command window. Okay, so you can see here from the very beginning just now, it starts from here. Okay, so we run the u value just now, so this is the value. We run y value, so these are the values, and then we run all these lines from y equals to blank matrix and t equals to blank matrix until n. Okay, so the value, the first iteration where k equals to 1, it only assign y equals to 1 value, t, theta just now, the first one we assign the first column, and then the second one, this, we assign this value, okay, and then the second iteration we go to the second row of first column, and then we assign t, okay, the first column, second row, and then the third equation just now we assign this value, and then we go to the third iteration, k equals to 4, okay, so we have this value for y, and then the second equation, this equation, we get this value, and then the third equation we get this value. Done. Okay, so you can see how Matlab works. It runs line by line. Okay, if we have iteration, for example this 4 until here, so it will iterate, okay, until the end. So for this one, k equals to 2, 3 and 4. After that you go to the next line. So what is this actually? This one is transpose t times y. So it comes from here, transpose t times y. Okay, right, so this is how we create transpose. So t dash, so this one is transpose of t, so we can see this is our t. If I run this only, t transpose F9, so this t transpose equals to this, the same value but different arrangement. This one is 3 times 2, this one is 2 times 3, okay, and then this t transpose I multiply with y, and I store it in this variable, okay, trans t y, okay, so I run this one F9, so I will get this value. So this value is exactly the same with this, okay, right, so we already finish up this theta transpose times y. So what about this one? Okay, we go back to Matlab. Okay, that one is transpose t times t. Okay, so I run this F9, so I have these values. Okay, so this one is exactly the same value with this one, and then we have to inverse it, -1, right? So we go back to Matlab. So this one is the inverse transpose t times t, okay, but this time I multiply all together this with the first trans t times y just now, this one, okay, so all of this will give you the b beta hat just now, so I use b hat, beta hat, okay, so this one is from the our original equation just now, this one beta hat, okay, we are expected to have this value a and b, right? So let's see, we go back to our Matlab and run this one F9. So see, we get our value of beta a and b. Okay, simple, right? So what are the remaining here? So all of these are how I represent our result. Okay, since this is a table only, right? So we have the value of u and y. Okay, so it is not clear if we look it as values only. What if we change it into plottings? Okay, so I use this. CLF is clear figure. Okay, if there is no figure, I can just create figure like this. Okay, I put here in command window. I use FIGURE, enter. So we will have our, sorry, it shouldn't be caps lock. Okay, figure, enter, ash, figure. Okay, so we have our figure. We can dock it in our Matlab environment by using this button. So we have our figure here. Okay, and then grid F9. So we have our graph with grids, and then this one is the axis limit. Okay, so here it is from 0 to 1 for y-axis, 0 to 1 for uh, x-axis, whereas we have our values as this one, right? See, this is x, this is y, right? So this is the limitation of our axis. This is how we do it. Okay, so the first value in our matrix is the minimum x, and then maximum x, minimum y, maximum y. Okay, so we have here, I put min u. So we have this u, right? So the minimum value of this. So the minimum value is -1, and then I minus 1, so that we have some tolerance on the graph. Same goes to the maximum. So max u, maximum value of this is 1, and then I add up one value. So the maximum of y of x will be 2, and then this is the minimum of y-axis. So see, min y. Okay, so y, the minimum value is negative 0.641, and then I minus 1. So our limit, bottom limit of y will be negative 1.648, and then the maximum will be the maximum of y. So this, the maximum value is 0.481 plus 1, so 1.481 will be our maximum. So if I run this line by using F9 just now, okay, so look at here, we can see that the new range of x and range of y is set up by using this line. Okay, okay, pause. What is pause? Pause is we pause our figure for 1 second. I put it here 1. If you want half a second, so we put it 0.5 here. So it's up to you. And I hold it so that this value, this graph will remain like this, and I can superimpose whatever plotting after that. Okay, so I plot it by one. Okay, so I can see here, I put here 4, I equals to 1 until numeral of u, number of element of u is 4 just now, right? So I equals to 1 until 4. Okay, so every iteration will plot 1 point. Okay, so this one is to plot u versus y. Okay, from here. Okay, so if I run from here until here, it will pause for 1 second. It will hold this figure, and then it will plot one by one. So let's see, I use F9. See, go back here, here. So from these two sets of data, so you'll have this, okay, 4 points from here, goes here, goes here, and finally goes back here, right? What about the results? We have already the value of b hat just now, okay? We have value of a and b. So from our equation, so we already have this equation, the general equation, but now we have the value of a and b. And then when we put the value of u here and also the value of y from here, so it means that this equation is completed already. So we can plot it, right? Okay, so from this, what I do is, this is the equation y final. Okay, see, negative b hat 1, which is a, times y, k minus 1, and then b hat 2, which is b value, times u, k minus 1. Okay, so what I do here is actually I I find all the values of this equation. From this equation, all the values of y, the plotting values. Okay, again I use axis and this notation, parenthesis, to recreate my uh, x and y axis limits, okay, to assure that it will cover everything from the data values and also the points that we have from the equation just now. And then this is how we plot. See, for I equals 2 until number of element 4 just now, okay, and then I plot it one by one, point by point. Okay, so if I run from here just now until here, you can see the figure superimposed by the value from this equation. Okay, I use F9. See, we have 1, 2, 3 points instead of 4, because you start k equals to 2, 3, and 4, right? So we have these values. Okay, so this is the comparison between the data and also the estimated lines that we have from this, right? Okay, so that's it for the case study from this problem that we had in our class before. From here, what if we want to use least square estimation also, but with different set of data? Okay, we go back to our Matlab just now, and actually I also have this project, LSE coding project. Just now is LSE coding, the one from our case study. This one is if we use different set of data. Okay, I prepared to you, okay, this is the original one. Okay, I prepared to you these two sets of data, this one and this one. Okay, so let's look at this first one. Disable this one. Okay, so for these two, as you can see here, this one is also a plotting. So let's see if we clear everything and I plot this u and y, what will happen? First line, second point, third point. Okay, so this is almost a straight line, right? Almost a straight line. Okay, the y and the t is remain the same equation, but for this case, our expected equation, since we can see this is a straight line, so the equation should be y equals to mx, right? So only m and x. Okay, so we delete this one, since our t from the case study previously is two column, right? So we delete the second column. Okay, and the equation should be mx. So this one is the x, right? So it shouldn't be this square. Okay, so it's supposed to be like this only, and the values is depending on the directly the value of x. Okay, this x of k will get your y of this k. Okay, this x, this y. So is there's no k minus 1, it's only k only. Okay, so for the y it's only yk, and for the t, the theta, is only uk. Right, so if you run this and we find also the transpose t times y, and we find the transpose t times t, and we find the b hat, and then we find the equation. Okay, look at this equation. Remember for this case, the expected result, the expected line is y equals to mx, and we try to find the value of m. Okay, so it is not m x times to the power of 2. Okay, it's only mx. Okay, so the x is this one. Okay, so this is equation. So b hat is the m. Okay, y equals to mx, so this is the m. And since we know that the value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we expect that the value of m, the slope, is around value of 1, right? So if we run from here until here by using F9, and we look at the value of b hat, so b hat value is 1.0013. It means that our m, f equals to mx just now, our m, the slope is around 1. So this is correct. Okay, since we have all the values already, okay, from here, y final, if we plot it, you will have a straight line. See, it's a straight line as compared to the data. So this is how we use LSE, least square estimation, to find the transfer function, or to find the trend line of this line, the data. Okay, let's say we go to our second set of data, this one. You disable the first one, and we look at our data, plotting. Okay, you can see here, x equals to 1, it goes 1. X equals to 2, it goes 4. X equals to 3, it goes 9. 4, it goes around 16. 5, it goes around 25. 6, it goes around 36. 7, it goes around 49. 8, it goes around 64. 9, it goes around 81. And 10, it goes around 100. So we know that the equation is supposed to be, the expected equation is supposed to be a y equals to x squared, or we have coefficient times x squared, right? So for this case, I put this value around that values, okay? And we expect that if the equation is f equals to m times x squared, the m is also around value of 1, okay? So same here, we find the value of y and t, okay? But for this case, since our equation just now is x squared, so I put here x to the power of 2, okay? And then same goes to our final equation just here, uk we have to power 2, okay? What we are looking for, this b hat, the m value, the coefficient that multiply with the value of x squared, okay? Since I put it just now, the value is around x squared only, so m is expected to be the value around 1, value of 1, okay? So if you run from here until here and we check the value of b hat, see, the value is around 1, okay? So we know that the plotting of y final, if we have b hat, the m is around 1, and then times x squared, so it will be a curve, right? So again, we try to plot it, and we will have that curve of x squared, okay? So the red one is the values that we have, the data, and then this is the equation and the points that we had from our LSE, least square estimation, okay? Right, so this is how you create a coding to solve LSE, okay? So I will show you later how to solve other types of problem, okay? For this case, I want you to find, for example, okay, a set of data, okay, for y equals to uh, 3 times x cubed, okay? You find a roughly data about that value, and then you use this LSE. Can you get that uh, coefficient 3, okay? So it's y time y equals to 3 times x cubed. Cube means the power of 3, right? Okay, so try to find it. If you can get your b hat equals around 3, and then you can get the line almost the same with the data that you create earlier, so you are done with this one, right? So all the best, good luck, okay, and try to do it within this week, right? See you later.